Okay, so this section 5.1 is on perpendicular and angle bisectors. So we'll talk more about that picture in the class, but let's look at the theorems. If a point is on the perpendicular bisector of a segment, then it is equal distance from the endpoints of the segment. So if we look at this picture, the perpendicular bisector is this. That's the perpendicular bisector. The segment is this. So what that means is that blue line is perpendicular to the red line, and it cuts it in half. The converse from it is if this point P is equal distance from the endpoints of a segment, then it is on the perpendicular bisector. So what that means is if any point on the perpendicular bisector, I mean, I could extend this perpendicular bisector forever and ever, and any point on it is equal distance x to y. I mean, it could even be this close. It is equal distance. Okay? So now if we look at a picture, and I want to park, so this is the zoo entrance and the park entrance, and if I want to park out here on the street, the same distance away from the park entrance and the zoo entrance. And I do this a lot at Walmart. You know, park between the doors. If I know I have to go to one end, I might be coming out the other. But if I found the midpoint between the two of them and then drew a perpendicular, let me draw this line first. And then drew a perpendicular line where it meets the street is where I should park. And that means that this point is equal distance to the park entrance as it is to the zoo entrance. So Mr. Lee can use the perpendicular bisector of the segment that connects the two entrances to find the location. And here's a drawing. They actually drew it. Mr. Lee should park his cart at T because it is equal distance from both entrances. If a point is on the bisector of an angle, then it is equal distance from the two sides of the angle. So if a point is on the bisector, here's the angle bisector, you know that because of these two lines. And if a point is on it, it is equal distance to the sides of the angle. So equal distance, okay? And then you can also tell if a point is equal distance to the sides of an angle, then it is an angle bisector. All right, so what is the value of AD? So AC is the perpendicular bisector. See, it's perpendicular and it bisects this. So I know that A is on it and it's equal distance to the ends of the segment. So what about these two? This is the perpendicular bisector. So this equals this. 5n minus 2 equals 2n plus 7. I think we will do B in class. All right, so applying it. JL is the angle bisector, so I know that L is equal distance. So 2x plus 3 equals 4x, not plus, minus 11. And I'm not going to solve any of these. I'm just going to write out. I think we will do these two in class. And I think let's just run through a few of these. Stop the video, do them, and see if you've gotten them right, okay? Okay, so we'll do that bottom section in class, but see if you've gotten these right. Check those answers, and I guess that's it for the video.